Hello everyone, my name's Andrew. I'm one of the directors at the ASC, and every month we do an ASC Lab session, and it's kind of an informal chat really, where we kind of look at kind of new things which are coming up in the industry. We don't have kind of too much of a rigid agenda. I'm not trying to push anything, I'm not trying to sell anything, I'm just trying to share some new technology which has come out, and hopefully we can get a bit of discussion and we could all learn something along the way. It feels like everything is moving so fast at the moment, and so the idea of these sessions is just to kind of allow us all to kind of get back up to a similar level, so that I don't know, we can kind of stay informed and stay up to date with what's going on. So today's session, I wanted to kind of cover something which is kind of fairly close to my heart at the moment. I've been doing quite a bit of work in that area, and it's all around AIs and APIs and MCPs and how all those things kind of interact together. And I'm not the kind of the person who invented all this stuff. I'm just a very enthusiastic geek who kind of wants to share what I've learned so far. And if you want to kind of contribute your understandings as well to the group, then please do. I'm not the authority on this. I'm just, hopefully I know stuff which you'll learn from as well. So let me just share my screen. So yeah, as I said before, just feel free to raise your hand, ask a question. Let's keep this kind of fairly informal. So what I wanted to do today is kind of demystify some of the 3-letter acronyms or TLAs which have come out over the past year or so, and some have been around for a lot longer. So specifically APIs, MCPs, and AI, and kind of go through what they mean and how they interact together. And what I'll also do is actually do a real example of how they're working. So let's just jump straight in. So yeah, what I'm hoping to do is some kind of plain English explanations about what these things are, how they work behind the scenes. I'll then do that live demo, and then we can look at the big picture and see how they all kind of come together. So first of all, let's just kind of jump into what is an API. So I'm sure we've all heard what API is, or have them kind of thrown around a lot, but they are kind of almost like the little bits of code behind almost every application that you kind of work with these days. So it kind of acts as like a messenger between you and how the system works, and it puts it into a very kind of particular format so that the system knows how to do it, how to interact with it. So as an example, you'll make a request, the API will go, okay, you want to do that, I'll put it into the language which my system understands, and then the system will do something with it. And then it may kind of bring you back the result, or it may just do something on the system. So if you think of it in terms of like a database update, you could do something where you go, make this change to my data, it will then send that request to the database, it will then make that change. Equally, you could have something that says, go and get me this data from the database. And so you'll go make this request to the API. The API will then return that data back and give you what you asked for. And so the idea behind the API is so that you can put kind of these kind of extra checks and measures and authentication in there, so that you're not directly connecting to said database and breaking things which you shouldn't be breaking, which is kind of key to most systems. So that's kind of high level what an API is. And then a nice little example here is kind of to think of it as like a restaurant. So you are in the restaurant, you don't really know how the restaurant works, but you've got someone called a waiter, and they'll talk to you, and they'll kind of take your order, and they'll turn what you've asked for into how the kitchen will understand it. So they'll write their little list, and they'll take the notes, and they'll pass that on to the kitchen, and then once it's ready, they'll bring you the food back. At least you hope. And then if you kind of almost think about the bigger picture about how kind of companies like McDonald's and things are working, you go in there and you kind of fill in your form, or you use the app or something. And so what that's doing behind the scenes is using these APIs to connect to the kitchen, so that the what you request is then going into the format which the kitchen understands, and then it's coming back. So yeah, you're using these APIs all the time. Well, I'm assuming you go to McDonald's, but if you go to Starbucks or any of the others, then I'm sure you're using those. So then if we kind of jump into what an API actually looks like, there's this thing called the REST framework, which I'm not going to go into too much, but it uses these kind of common phrases like a get. So get will then go and fetch some data. There's other ones called post and other ones, but I won't go into those. And so it's typically kind of a string of text. And so the get, and then it will go to the host. And then typically there's like this endpoint afterwards, which says, okay, these are the users, and then I want number 42. And so what that will then do is send that request to the server and pass in that information. And then what comes back is what's in this part here, which is the response. And then this is typically in the JSON format, which is kind of just very text heavy strings. And so it puts it into a format which is typically fairly easy to read, but also very easy for a computer to understand as well. Okay, so hopefully this is making sense so far. So then what we're going to do next is then look at the AI part of it. So I'm sure we've all used AI. Ralph, you said you haven't used AI, but I'm sure you have, but not really known about it. So AI will kind of build up the language for you. It's built upon vast amounts of data which has been either on the internet or from books or from other text, and it's kind of put all that together, understood the kind of how the language is kind of put together. So if you say the cat sat on the, it will kind of use probabilities and things to work out the next word is probably Matt. And then what has then happened over the kind of past couple of years is that those models for building those AI models has kind of been refined to either address particular needs. So whether it's coding or whether it's translations or summarizing or whether it's text image understanding. So those models have then been refined and made better depending on what your use case is. So as we all kind of know, you're also going to get a lot of kind of non-real answers in AI. So there's been a lot of I don't know, people are kind of quick to bash AI, saying, oh, look how stupid it is. I've asked it this simple question and it's given me the wrong result back. And yeah, because it's largely working on a probability basis. But what I'll demonstrate in a moment is where we can actually then use things like APIs with AIs so that the information that you get back is actually exactly what you need it to be and not what AI has kind of come up with. But in between these two things, so you've got your APIs and your AIs, you then have something called MCPs. And so that's where this next part kind of comes in. So MCP is probably the acronym that least people have heard of. It was something that was been developed by Claude or Anthropic, which is one of the big kind of AI players. And what it is kind of like the almost like the framework for how APIs can be used within AIs. So it passes the I suppose it gives the AI the understanding of how the API will work. Because otherwise, if you're just doing it with the kind of techie endpoints, which I demonstrated earlier, it doesn't really know what it's doing. So the MCP provides the context for how the AI should interact with the API. I'll go through an example in a moment just so that it's a little bit clearer. But if we kind of look at how it all kind of fits together in this kind of series of points, what you'll do is you'll ask your question and your question will go into the AI. So the AI will kind of interpret it in the good way that it does. And then it will connect it to the MCP. The MCP will then pass will translate your request from the AI into the API, and then it will go and do something on the system. So it will then kind of either get you the results back and present them back into where you ask the question, or it'll actually do something on the platform. So an example that we've got here, kind of a geeky survey example, is how many responses did we get in our survey this week? So the AI will receive that question and it will use the MCP to connect the survey to the survey platform's API. So then the API will go and pull the information and then return back the answer back into your AI. So that's where it's really kind of then starting to connect with what actual things are happening, actual live systems, and not relying on not relying on AI just to make it up. So a long time ago, I was doing a brand health study, and I asked AI how many people like Kit Kats in the UK, and it went off and it wrote me a Python script, and it says if you kind of delved into it, it just said number of people who like Kit Kats 15, sample 100, therefore the answer is 15%. And so it's just like it just completely made up the answers. Whereas what we can do now with this MCPs and then connecting to the APIs is actually connect directly to the survey platforms to answer that question. And that's when it's going to then bring back the actual result. There's a lot of little bits in between there, as I'm sure a lot of you will understand because we all work in survey data. It's not always as simple as that. So what I thought I would do is kind of jump into actually doing this in a bit more of a kind of a techie environment, just to kind of show you end to end, and it adds a little bit more kind of context of how these things come together. Those of you who came to my previous ASC Lab session, which is all about how to actually just get going with Visual Studio Code, if you're not familiar with it, then that's available on the ASC website and our YouTube channel. So what I'm going to do here is actually demonstrate how to build an API, and it's not that scary. It's all very simple these days. And then I'm not going to use Claude to show how to demonstrate the code, but then I'm actually going to use ChatGPT and embed the API in ChatGPT and then call the API that we write from within ChatGPT to give us the answers. So hopefully it all works in the live demo. So bear with me if it doesn't. So here we go. Just make sure I've got the right screen. Okay. So what I thought I'd do is the example which, I don't know, hit the headlines in the BBC News and all the other news outlets about how AI didn't know how many R's in the word strawberry. So it was kind of a common thing which came out and everyone laughed and went, oh, look how stupid AI is. But they were kind of asking the wrong questions. So what I thought I'd do is write an API which allows us to pass in a word and it will count how many occurrences of a particular letter there are. So it's a really stupid example. And in real life, you'll develop your APIs, which will be a bit more sophisticated than this, but it's a good example. So I'm doing this all in Python, and this is Visual Studio. So let me just make this a little bit bigger. But in say 10 lines of code, literally 10 lines of code, I'm building an API. So I'm using this package called Fast API, which is quickly becoming one of the kind of the standards for building an API, because it puts all the right things in the right places behind the scenes. So all we have to do as developers is write kind of fairly simple functions. And even if you don't know Python, I think you could probably look at this and kind of work out what it's doing. And allows us just to kind of focus on actually what we want the logic to do rather than thinking about how the API works. So that's what I've got here. So this is the function is going to pass in 2 parameters of the text that we want to pass in, so strawberry, and then the letter. So this will be the letter R. It's then just doing a quick check that we've got actually letters that have been passed into the function, and then what it's going to return is the letter that we asked for, the text that we asked for, and then counting how many occurrences of a particular letter are. And what I've done here is I've put it just all in lowercase so that we're not going to get the difference between a capital R and a lowercase r. So that's all it does, and that's our API. So what I then do is just run that, and so let me just cancel this and then run it. So what that's telling us down the bottom is that it's currently running on my system, and so I can, if I click on here, it will then open it up for me. So where's my other screen? Blessed with multiple monitors, but I don't know where they are. So what it's done, it's taken me to this website, and I don't have a almost like a default page for the API because I've only got one link. But what you can do on any fast API connection is put this /docs. And what it will do is actually give you a really kind of simple interface based on what you've put. So here it's got the count endpoint, and then it's got the two parameters that we requested in our function, so text and letter. And then what we can do is hit this little button here of try it out. So here I'm going to pass in the word strawberry and the letter R. And so I'm going to then execute that. And so it's then run the request, and it puts it into the kind of the geeky language which it requires. This is actually the request that it's passed. So if you remember my PowerPoint slide, it's doing this kind of HTTP, passing in my host, the endpoint count, and then at the parameters text equals strawberry, letter equals R. And then here it's given me the response. So the letter is R, text is strawberry, and the count is 3. So very simple, okay? But what you can see here is hopefully how the API is then working. So this is all very good and lovely, and we can actually, if you can think of it, you can write an API to do it. So examples of ones which I've done once is you wanted to remove the background from a image, so that if you've got a portrait picture of someone and you want to remove all the kind of the noise behind them, there's a Python library called removebg. And so what you can do is build a fast API thing which wraps around the Python library removebg. You pass in your image, you press run, and it will give you the answer back. So there's a lot of websites that will do this for you, and now they're starting to charge for you, but you can write your own really quite quickly. Again, maybe in about 10 lines of code, and it will do the same thing for you. And they can be as big and as complex as you like. So that's that. So then at the minute, this is running off my local computer. But what I really want to do is actually push this into ChatGPT. And to do that, I need to make it public facing. And there's a kind of there's a service called ngrok, which will take my API and put it make it publicly accessible for the time that I have it running. So I've set that up already. So let me just go to that. This is kind of, you don't really need to know about it too much. That's why I'm kind of skipping over it quite fast. So let me just restart that. So it's something that you can download and install on your machine, and then as soon as I run this piece of code, it will take the service which is running on my computer in this port, and it will make it available in a public-facing way. So again, you don't want to do this with meaning-thing things with client-facing data and all the rest of it, but for this silly example, it's fine. And so what happens now is that I've got this endpoint which I can use. And so if I actually put this into my browser, I change this part to that bit, it actually goes to exactly the same thing, but it's now actually a publicly accessible link. So if anybody actually copies this on your own computer right now, it should also work. In fact, I'll do that and we'll see if it breaks my system as you all rapidly see how many letter R's are in the word strawberry. So this is now a publicly accessible link, but only when I'm running it on my computer. So after this meeting, I'll turn it off and it won't work. So just to give you a heads up. So that's that. So now I want to make this API accessible to ChatGPT. So this is kind of like the poor man's version of an MCP. To build a full MCP takes a bit more time, but this is kind of the quick version which you can do actually in chat. So in ChatGPT, there's this, if you pay for the professional version, you've got the ability to create your own, what they call create your own GPT. And so you can give it a name of count letters GPT, give it description, instructions, etc. But the best bit is hidden kind of at the very bottom, and it's this called create new action. And it's kind of hidden, and it's one of these little things that not many people know about. So that's why I'm sharing it today. So when we press create new action, what we can then do is actually put in the details of our API in here. And you'll see here it says enter your open API schema here. And we'll all kind of look at each other and go, what's an open API schema? But we don't really need to think about it too much, because in that fast API framework that we used, there's a little button here that says open API. And so what this has done is actually put it all into the full definition of what the ChatGPT will require. And now I'm just going to put you on mute. Sorry, but that cough sounds awful. So what we can then do is copy this into our ChatGPT here. And here, where is the one I prepared earlier? So let's go back here. So let's go in here. Nope, doing it wrong. And so here I've copied it in. I didn't do this live because it also needed to have this extra little bit in here. But yeah, now I've now got a connection to my API which I wrote, which is running on my computer in ChatGPT. Now in real life, if you're doing this for a real kind of problem, let's say you wanted to create a API that does weighting of survey data or something like that, but you can then put it behind authentication layers. So if you've got if you don't want the whole world to be able to access your API, which is probably true, then you can put authentication in front of it to prevent people from doing that. So it can kind of grow with what your requirements are. So that's now in here. So then what I can then do is take this bit of summary text. So count occurrences of the letter R in text, Andrew Labrie. And run that. And fingers crossed. Oh, it's not pulled my model. Let's do it in the other way. This is where it's just a bit annoying. Live demos, yay. Here's the one that I prepared earlier. So count occurrence of the letter R in the text Andrew Labrie. So then what it's done is actually connected to my API, and then I can actually see what it's called. So this is where we can then start to get an audit trail of what it's done to get to the result that it's come from. So here I've passed in the parameters Andrew Labrie and R, and then it's getting the response back to do the answer. Now this is one I prepared earlier, and so it wasn't working completely. So let's just try it again. Oh dear, come on, sorry. I do promise it does work. So let's go back to Yay! So here it's now talking to the API. Gotta love a live demo. And so it's then passed in the details into my API and getting me the results back. And so this should also work for anything. So let's do it again. So count the letter R in the text. Strawberry. So then now it's running that code for us. And I think if we were to go back to my API and jump into the code, we should start to see it actually running these requests for us live in the code, because it's going through our API to make that connection. Okay, before I move on away from my live demo, which kind of didn't go exactly to plan, does anybody have any questions before I move on to the next bit? No.
So is that always going to be running on your local machine, or can it? Or
yes.
Did you say you can publish it so it runs somewhere else?
Exactly. So you can host this API almost anywhere you like. So if you are in like a cloud environment like Amazon Web Services, then you can actually wrap this in what's called a Lambda function, and then that gives you its own endpoint, and so it's then purely hosted in that environment, and so you can call it anytime. So yeah, you've got loads of options of where you can actually host. It's almost like hosting a website. So you then host your APIs somewhere, and then as long as it's publicly accessible, you can then connect it up to either in the ChatGPT actions like I did there, or Copilot's got a similar one, or Claude's got a similar one, or you can build an MCP around your API, which will then connect to the AI interface. Hopefully, does that answer your question?
Yes, thanks.
All right, cool. Fab. Okay. So let's whiz back to my presentation now. So as with all AI tools, and you saw that it didn't work first time for me, be careful. It's still very much an emerging technology, and you need to kind of make sure that you check what is actually being done when it's being done. So, I mean, it just goes with all kind of uses of AI, is don't use it blindly. And then the other kind of key thing, I mean, there's a few points on this, but make sure you understand your organization's policy on using AI, and then making sure you're not using client sensitive data in AI, because you need to make sure that you know where that data is going. The benefit of using your own API is that you have a lot more control of where that data is going, rather than just blindly applying it to what someone else has written. So then if we kind of think about then where could we use this in our own work? So there's, I'm guessing all of us here have something to do with survey data. So the survey platforms that you currently use, do they have an API? If they do, could you actually automate the process of gathering the number of counts on a daily basis, and getting those results back? Now this could just actually, you don't need the AI part of this. You could just do this as purely an API call, and many of you may be already doing this. But all these kind of common repetitive tasks which you do on a frequent basis, can we automate those with an AI, with an API? If you then start to combine those APIs with the AI, Claude has got a really good, almost like PowerPoint integration now, which is where Claude has built a PowerPoint MCP, which connects to PowerPoint's AI API, which then builds you a PowerPoint deck. And those of you who have played with this will recognize that this presentation, which I'm doing today, has been completely written by Claude's PowerPoint generation. It always has this kind of very similar theme. But what it can do now is actually incredible. I'm just always shocked about how fast it can pull this together. And because this is a free session and there's no client data involved, I was very happy to use and experiment with Claude PowerPoint presentation in this example. So yeah, as I mentioned before, you can also do quite a lot of repetitive tasks with the APIs. There's potential for doing data cleaning, explaining key findings, and linking with external data. It's almost every kind of modern platform now has an API, and so it's worth kind of digging around in it a little bit and seeing how it can make your life a little bit easier. So just to summarize back then, so the APIs are those kind of little kind of translations, your waiters in the restaurant who will kind of take your request and put it into the format that your system will need or uses. AI is really good for pattern recognition and building languages and building stories and compiling information, but getting you exact results, it's not always going to give you the right answer, and especially if it's the exact result is hidden in a database which AI doesn't have access to. Your MCPs are the connections between your API and your AI. So a lot of the big modern platforms now have MCPs, which make that process easier. A couple of examples which I've used frequently are the Tableau MCP. So with the Tableau MCP, I can connect to my Tableau dashboards, which I've created, and start interrogating the data directly within the AI. And so what it's doing, it's taking my AI request, translating it into the MCP. The MCP is then pushing that into the API of Tableau, and then it's going to bring me with the results back. Another example which I've used recently is Figma. Figma is like a drawing package, and it did exactly the same thing. So I said, hey, AI, can you draw me a banner for this particular requirement? I want the background to be purple. I want this image in it. And it kind of took that request, it translated it through the MCPs into the AI, into the APIs, and did that action actually live within the Figma interface on my machine. It was incredible. So all these tools are then starting to work together, and because they're all written in these kind of common formats, then they all kind of work and talk to each other in this nice way. And so yeah, and finally, if you kind of went again to my previous lab sessions, you don't really need to know to code anymore, because you can use the AI to help you code all the kind of different semantics of how these different things connect to each other. But if you can understand the concepts of how these tools work, then it puts you in a really good stead for actually kind of seeing where there's opportunities for using APIs, MCPs, and AI in the future in the way that you work. Okay, any questions? We've got quite a bit of time, so I'm happy to kind of dive in and do a few more examples if that would be useful. Nikki, you have a question?
Yeah, I don't know whether this is outside the scope of what you've discussed today, but one of the things I've always struggled to get my head around is the way AI teaches itself. When you hear about all these algorithms, and I imagine they were just going round and round and round saying, no, you didn't get it right. No, you didn't. Oh, you got it right. Right. Let's adapt the next version of the algorithm. Are you able to shed any more light on that in the same excellent way you explain this stuff?
I don't know the full extent of it, but from how I've been working with it and my understanding of it, and please someone else correct me if I'm wrong, is that as you ask questions into AI on a kind of a personal level, then it will kind of store some of the kind of the key information about who you are almost in a separate file, almost like a little kind of cache file of this is what I know about you. And so when it then takes your next request, it may refer back to that file, that what it knows about you or your previous requests. And it's used its own AI to make that personal history of who you are easy for itself to read. And so it will kind of keep referring back to that and that and that. So if you've got a subscription to, say, Open to ChatGPT or to Claude, then behind the scenes there'll be like the personal information that it's gathering about who you are and what the typical work is that you do, unless you turn that feature off. So
you're the one that needs to keep telling it, no, that's not right. It won't work it out on its own.
Yeah, I mean, if it's I don't know, someone else correct me, but if you need it to say no, that's not right, what you can do now is say, here's the source which you should be looking at, and you can pass it in like the URL of, no, you need to look at, I don't know, BBC News or Wikipedia page, and say, using this as your source, now derive the answer. So if you need to narrow down its focus, then
no, right.
Direct
so back to those the better the prompts, the better the answer.
Yeah. How it works on a big scale and how it kind of continuously improves, I think that's beyond my pay grade, and I don't really know. If anybody else knows it, then welcome to it. Something which I hadn't shown you, which I was meant to, is how you can actually run AI locally on your machine. So I don't know if anybody's done this, but there's a application called LM Studio, and so that's what's running here. I'm very lucky that I've got a very big computer underneath my desk, which allows me to run AI locally on my machine. So here I ask my local AI how I'm doing, and then it's then using this model here, this AI model behind the scenes, which I've downloaded. And then this is the thought process that it went through to answer my simple question of, hi, local AI, how are you? And it went through all of these kind of prompts, and it talked to itself for a little bit, and then it gave me the response here. So if you do want to understand how your AIs are working, I find kind of delving into this LM Studio is a really good way, because what this will kind of give you, warts and all of the things it's doing behind the scenes. So down here you can see how many tokens it's used, how many seconds it's taken to derive that answer, and it kind of gets into the kind of the nitty-gritty geeky layer of how it's come up with that response. And then
really interesting. Yeah,
and then what you can do is then down the side here you can look at all the different models which are available. So, oh no, sorry, this one. So it's almost like a marketplace of different AI models that you can use and download. And then each one has been engineered and developed by a different company, which is reflected in the logos. But they all have been almost like fine-tuned to do different things, and based on different data sets. So I mean, I don't know enough about these, but you can see, I mean, they're being developed thick and fast, and also downloaded a significant amount of times. So this is the latest one from Google. This 26B means it's got 26 billion parameters in it. And then if you look down here, that's 18 gigabytes of data just to download it. And so to then run it, you need a kind of fairly chunky machine to make sure that it's actually giving you the answers in a speedy way. And so what you can do with this list of marketplace models is choose which one is best for you. If you've only got a small computer, then don't download the biggest model, download a smaller one. If you're doing something that's very specific to coding, for example, then maybe it's better to find a model which has been fine-tuned to support reasoning and has been tuned on actual code, rather than one that's been fine-tuned on translations or something.
Can you not use them remotely from where they are in the cloud?
You can pay for that service,
okay.
But then you've got to pay for your token usage. And so if you're just experimenting and you don't want to kind of run up a massive bill, then running it locally is the kind of the cheaper way. So yeah.
Fun. That's my weekend sorted.
Only if you've got a good computer. Cool. Any other questions at all? let me phrase it differently. Is there something that you were hoping to learn that you haven't learnt? Or have all of your questions been answered?
That's very impressive.
It is impressive, isn't it? Or maybe the mute button doesn't know how to turn off for everyone.
Oh, have you forced everyone to mute?
I don't know.
Oh, no, because I'm talking.
Fab. So, yeah, I hope you found this useful. I'll try and wrap up now because there's, as there aren't any other questions. What I would really encourage you to do is to keep exploring and asking questions and being curious about all this AI, MCPs and APIs and how they interact together. If you're a tool that you use on a regular basis has an API, delve into it. Go back to my previous ASC Lab session, which is how to get started with Visual Studio and using AI to start vibe coding, and then reference the developer tool library for that API and say, I'm new to this, how can I start using this API in my work? And then see if it starts developing you some APIs, which you can then think about how you can then start implementing them. So as an example, if you're, again, we're using, say, a Decipher platform, they've got a good API, you could then regularly download the data set, the survey data every day, or when you put a request in, and take all of that kind of heartache of clicking through all the different options that you need, you can just codify it. And so it's just really worth kind of playing with and seeing where it's going. For me, this is where the industry is going. So what I've demonstrated here today is the layer below the term AI agent. So this is how AI agents work, and the layer underneath. So understanding this layer, you can then see how things evolve. And when AI agents aren't the big thing, what will happen is that there'll be another component in the API MCP AI framework, or something will have evolved in that, and then that's how it will keep going. So yeah, understanding these underlying technologies is really important. Okay, I'll stop talking now. Thank you very much for your Fridays. You've got an extra 15 minutes to do with your Friday morning. So thank you very much for your time.
Thank you.
Thanks.